There's two separate events. Well, there's three here, but there's two main ones. One is the one that forms the myelonetic fabric, and then that's been overprinted by a set of folds. And those folds, when you look at them, the folds vary in their size a little bit. They vary in how open or tight they are, and the fold hinge, the plunge of it varies, and it's going both that way and that way within the axial plane. And so that variation in strain is causing a rotation of the fold axis towards the extension direction.
Far, I'm short of words, actually, because there are so many things we were not doing right at our various core yards. We are just measuring only planar structures and leaving out lineations, which is supposed to point us to the pay shoots. So it is awesome. I'm looking forward to tomorrow's field work, which is also going to really add more knowledge to what we've learned in the classroom.
See how the foliation curves around like this? Okay. So over there, it was going like this, but this one's curving around. And you can see some sort of deflection and sort of like folding here. You can see that. So what do you think the fold axis is of this folding event?
Yeah, it's great. Pacers are really good. They've covered a lot of material to refresh. Most of it's a refresher, some of it's new, and they're constantly referring it back to real life examples, beautiful photos, and just what it means for your job in industry, which university prepares you with the fundamentals, but not always what's applicable for your actual role as a exploration geologist.
And what will happen when you guys take your measurements is you'll draw your stereo net, and you'll end up with your myelonetic fabric on there. And when you draw your fold axis on that, you will find that it will sit all the way along that, because it's sitting within that plane.
Forgotten like all my structural geology lessons before, and so it's a good refresher for me.
But it's good actually that we were able to join this, because I think we've learned a lot of things, and it's good that we have like names already on the features, structures that we see in the rocks.
Yeah.
So, yeah, it's actually interesting. And it's a good refresher, yes, because I almost forgot all my structural geology back in college.
Yeah, it's very educational because I've been logging, and there are like textures and structural features in the core that I don't know what the name is.
Yeah.
And so it's nice to actually have a name and what it actually means, and like what's its significance in the deposit that I'm working on. So.
And what are the reason behind the reason behind the formation?
Yeah.
Which way is it plunging? Can you take a guess? Is it plunging that way? Is it plunging, this way? Okay, so how do you tell that it's plunging that way? Yeah, but on this surface, there's not enough three-dimensional information. But if you look around, right? If you look around, this is a good one. This is a good one. That's exposed.
I'm going to do an in-house training with my team. Like Jun and Brett say, we can always come back to them for support. I wish I could bring them to Africa, Ghana. I will do my best to just impact whatever I've learned here to my team, and then we take it from there.
And so some places it'll have a low plunge, here it'll have a moderate plunge, back out here it'll be going the other way, and they'll all sit within there. So it's going up and down. And that's an important thing because it means your strain's heterogeneous, and heterogeneous strain's really good for moving fluids around.
I've actually got my first page of notes is a number of actions which I'm going to go back and work with my manager and hopefully improve what we do. We do a good job. We've got a lot of competent geos there, but they've highlighted a couple of gaps Jun and Brett have noticed in industry, and hopefully we can bring that through to the way we collect data, the way we interpret data, and the way we present our data through like geological history.
So there's a little fold here. Yeah, there's a little fold. Probably can't see it very well from there, but little fold there. You have to look at it this way, this direction. Little fold, and then the plunge is that way. So you can actually measure that. Does anyone want to measure that?
Measuring along this?
Yeah, like the fold axis is like this. Okay, so how do you measure? This is a lineation, okay? Lineation. So you need to be standing above, and you look down. You can use that slot to look down and align it like this. like that.
Hopefully not admit that I don't take enough lineation measurements. And I'll definitely start constructing things in a better geological history. So rather than just in my head, trying to actually document it, to communicate it to other team members ready for peer review and, carry on with success.
But the main permeability pathway has been over there. That's where the fluids have been coming in. And so you've been depositing veins into that as well, but they've copped all the deformation. These veins are all part of the same suite. They're all the same age. These just haven't suffered as much deformation. That was the conclusion you guys all reached? Yes. Yeah, okay, yeah. So Rod's saying over there you can actually see the entrainment of the veins into the higher strain zones.
So you only have to be approximate. 27 is 30, right? So it has to be along this circle, right? And 210. So I divide this into 30-degree increments as well. So I draw segments like this. Which way should that pole line, which way would it be plunging? To the west at how many degrees?
60.
That is 60. That is correct.
And I don't know if you guys had a look, but over there, the other side of that dead tree where those kids in the green shirt and so forth, you see the same vein sets over there. So what we're seeing is a fault zone going across there, which is your major permeability pathway. That is the thing that you would be looking for. And within that, the permeability has actually been quite fickle. What you're seeing is veins that are variably developed. There's no big veins here, yet just go along a few metres and there's quite large chunks of it in there.
60 degrees, that's south over here. Where is the pole of that plane?
It goes to north.
North? 30 degrees. Guys, you guys, this is easy for you. I'll have to make it harder.
Now that we know that we learn a lot of things, so maybe we will be able to apply that in our current work.
Yeah, for sure. It's got like a lot of industry aspect, like it's not just very academic, but what its applications are in the industry.